All right. Let's start. We're going to start with symbols of elements and what groups are they in. So number one, excuse me, the symbol for the element iodine, right? It's one of those simple ones. You may remember in the lecture part of the course that I mentioned some elements we inherited from the Middle Ages, the alchemists. And by the time this system of nomenclature was developed, we had some elements were already known. So those were the ones that were given single letters. Iodine's one of them. Oxygen's another. Nitrogen's another. Hydrogen's another. There are some with single letters that came afterwards, but to a large extent, the elements that have single letters, single capital letters, we inherited from the past. And in this case, iodine is the correct one. I means iodine. Now, do any of those others actually have a meaning? IO, there's no element. ID, there's no element. IE, there's no element. IN, yes, IN is an element. It's called indium. But to answer the question, I is the correct answer for number one. Number two, the symbol for lead. You may also recall that some of these symbols are not derived from the English, or they cannot be associated with English names. They're actually drawn from the Latin, and lead is one of those. Lead is PB, and that would be D. PB for plumbum. Now, LE, there's no element. P is phosphorus. L, there's no element. LD, I don't think there's an LD in there. Let me see. There's an LV. No, I don't think there's an LD. No, there's no LD. So the only two symbols that are recognized for elements are C and D, and the answer to this question is D. How about number three? Which of the following elements is an alkali metal? Now you have to know where your groups are. Alkali metals are the first column, the first group on the left-hand side of the periodic table. Those are alkali metals. So we look through here and see if any of these can be found in those groups. Lithium, sodium, potassium, rubidium, cesium, and francium. All right. The only one that fits that group is Na, which is sodium. All right. The Latin for that is natrum. That's sodium. It's not S. S is sulfur. Na is sodium. And I sincerely hope that students taking this course have memorized those roughly 60 element symbols that I asked you to memorize from the very beginning of the course. And if you haven't by now, then you've got a lot of catching up to do. Number four. An atom with 45 protons has a mass number of 100. It must contain how many neutrons? All right, so if it's an element and we don't know what it is, it doesn't matter to answer this question. 45 protons means, right, the atomic number of 45 is 45 protons. Okay. Where's the mass number? The mass number is 100. All right. That is protons plus neutrons. So 100 minus 45 is 55 neutrons. Pardon me. Nope. Okay. Well, I had an important phone call. Back to number 4. So we answered the question is 55 neutrons. Now, if you're curious, you can determine which element this is. All you need is the atomic number, which is 45. We go to the periodic table. We find 45 is ruthenium. Right? So that's one isotope of ruthenium. Oh, excuse me. No, I'm sorry. Ru is ruthenium. Rh is rhodium. This is rhodium. There we go, rhodium. I didn't ask you to memorize that one. All right, so uh, no problem there. Okay, that's 1 through 5. 4, let's go to 5. What's the most abundant element in the human body? All right. When we say the most abundant, what do we mean? Right? The largest number of atoms, or is it the most mass? Now, we didn't cover this in the lecture. This is in your textbook. So if you don't read the chapter, then you might miss this one. The most abundant by numbers of atoms is probably hydrogen, but the most abundant by mass is oxygen. And the reason for that is actually the reason for both of them is that the human body is, let's see, what are the estimates? Is it 78 or 9%, 76%, some high number water. That's the major component of our body. So our solvent is water. And that makes oxygen and hydrogen the most abundant by numbers. And since oxygen is 16 times the mass of hydrogen, oxygen is the most abundant by mass. So the best answer there is oxygen. All right, number 7. That's oxygen. Number 7. Symbol for copper. All right, there's another one. It's not CO. CO is cobalt. Cr is chromium. C is carbon. Copper is Cu. Cuprum. It's one of those Latin words. All right. The ones we skip are repetitive for some that I'm going to cover. All right. So let's go to number 10. An atom that has 54 protons. Okay. An atom that has 54 protons. It has 54 electrons. Does it? Yeah, 54 electrons. Okay. And 78 neutrons. So 78 neutrons is the information that's given in the problem. All right. What element is that? Well, all we need is this value right here. Number of protons. Look it up on your periodic table. 54 is xenon. And it's neutral. Same number of electrons as protons. All right. There's your answer. Number 12. Let's make some room here. Number 12. How many neutrons are there in one atom of Sc? What's Sc? Scandium. 2145. Okay. Now let's just check to be sure that there's not a mistake here. 21 protons. 21 protons. Yes, that's scandium. It's the first element in the transition group. All right. The question is, how many neutrons? If this is the number of protons, and this is protons plus neutrons, then all we have to do is subtract the number of protons. 24 neutrons. Okay? Very simple. Number 13. Which of these elements is a noble gas? Right? You just have to know where the noble gases are. They're the group on the far right of the table. And you see which one of these matches. Well, in the first place, if you're talking about a noble gas, you're talking about an element, not a compound. So CO2, you can throw that one out immediately. That's a compound. Nitrogen, hydrogen, oxygen are not noble gases, right? They are gases, yes, but they're not noble gases. The only noble gas in there is argon. Number 14. The chemical formula Al2O3. Al2O3. And we look at our choices to answer the question. But let's look at the formula. This is a compound. It has two different elements, right? And we're told how many, the ratio of atoms of oxygen to atoms of aluminum. For every two atoms of aluminum, we have three atoms of oxygen, right? And this is a metal and a non-metal, so it's an ionic compound. This is the simplest whole number ratio for that formula. If we actually had aluminum oxide, if we had a small amount, it might be a couple of billion atoms of each. Well, a couple of billion of this and maybe 3 billion of that. But if we had a bigger chunk, it might be 100 billion of this. And then the ratio for oxygen, right? So it's the simplest whole number ratio for that compound. All right, now let's see which one of these answers fits the bill. Let's see, we got any squirrely ones in there? None of these is correct. Okay, so the last one, E, yes, is none. None is correct. All right, so we look at the others and see if there is one correct, and then that automatically counts E out. Okay, A says 3 atoms of aluminum and 2 atoms of oxygen. Is that correct? No. Subscripts say 2 and 3, not 3 and 2, right? So A is wrong. B says 6 atoms of each element. No, it's 2 of one and 3 of the other. Okay. How about C? 2 atoms of aluminum, 3 atoms of oxygen. There's the one. That's the correct one. And D must also be false. 5 atoms of each? No. Now, 5 atoms total in that formula, but not 5 atoms of each. All right. Okay, so we found our answer. And with all multiple choice questions, pick the best answer. Sometimes the answer doesn't look like it's exactly what you want. And if you don't have the option for none of these, then you pick the best one. And in this case, we had one that fit better than none of these, and that was answer C. 15, silicon is the symbol for, or Si, excuse me, Si is the symbol for silicon. Number 17. How many of the following did Dalton not discuss in his atomic theory? So you need to understand what Dalton's atomic theory is, right? What are the postulates of Dalton's atomic theory? Right? What's the first one? All right, first one is atoms. Every substance is made up of small, indivisible parts. Right? He got that from the Greeks. But here's Dalton's genius. He said every element is composed of unique atoms. That is, the atoms of one element are different than the atoms of another element. Okay? He also said that compounds are, let's see, I'm not sure what the words he used. Let's just say associations of different elements. Okay? And then 4, chemical reactions. Chemical reactions simply rearrange atoms. Now, this theory explains all the laws that had been accumulated up to this point in the sciences about elements, chemistry. Right? He took care of Lavoisier's conservation of mass. He took care of Proust's law of definite proportions. He took care of his own law of multiple proportions with these parts to his atomic theory. Okay? So, which one of these does he not talk about? How many of the following did he not discuss? Dalton had no information about the structure of atoms. At this time, all he knew was that an atom was a jelly-filled bag, and each atom had different jelly in it. He didn't know about electrons, protons, neutrons, isotopes, right? He didn't even know about ions. Because to know about ions, you have to know about balances of charges in an atom. And there was no idea of how that could be accomplished because they didn't know about positive and negative charges in atoms. So Dalton didn't know about any of these. All 5 of them were foreign to him when he created or proposed the atomic theory. All right. We'll skip a few and come down to 20. The number of neutrons in Be. All right. This takes some detective work. First, you have to know what is Be. Beryllium. That's Be. Go to your periodic table. Let's just put in. Well, we are going to need the atomic number. Beryllium atomic number is 4. Okay. Now, in order to calculate the number of neutrons, we need to know the mass number. But the only thing we can get from the periodic table is a weighted average of the masses of beryllium isotopes. So what is the atomic mass given in our periodic table? Let's look. 9.01. 9.01 equals the atomic mass. Now that's not the mass number, and it's easy to tell because it's a fraction. Mass numbers are always whole numbers. But what we can deduce from this is the most common isotope. The most common isotope of this element is 9. 9 mass number. How do we know that? Because the averages put us very close to 9. The other isotopes don't drag the average away from 9 very far. So this is the most common isotope, 9, which means the number of neutrons equals 9 minus 4 equals 5. That's how you find the answer to this question. It takes a little more work than you're used to, I'm sure. But that's why you're taking this course, so you learn how to think. Okay, number 21. Which of the following is a non-metal? Right? What you have to know is where is that zigzag line that divides metals on the left, non-metals on the right. Once you've identified that line, then you can look at the possibilities here. Cerium, cesium, calcium, copper. Those are all on the left-hand side. Right? Well, let's see. From mine, it would be this way. Left-hand side of the periodic table. The right-hand side, the only one that's on the right-hand side is carbon. Carbon is a non-metal. The rest are metals. Let me pause my discussion for just a second. I want to see if I got any messages. Okay. Okay. All right. Let's get back to our business. All right, number 23. The symbol for the element mercury. All right. Mercury, I would suggest for mercury, you just memorize the symbol. Because the Latin word that goes with Hg is a little hard to tackle. Right? Hg is mercury. I think it's the Latin is hydrogenium. And it comes from the early modern era when mercury was since mercury is the only liquid metal at room temperature, they used hydro because water is liquid at room temperature too. So mercury is a second cousin to water in the mind of the early 17th century. Okay. So enough said about that. I would just memorize the symbol. 24, the symbol N stands for nitrogen. 24 is nitrogen. What about the others? Nickel? Nickel is Ni. Nobelium. Let's see. Nobelium is I'm having trouble finding nobelium. I think it definitely starts with an N. I think it's NH. No, it doesn't seem right. NH nobelium. NO. NO is nobelium. Niobium is not Ni, that's nickel. So we have to go to a different second letter for niobium. And let's see if I can find niobium. It's not a commonly used niobium. Nobelium, niobium. There's ND. NB. Yep, there it is. NB. This looks like a small n. Let me write that correctly. Those are capitals. Okay. Niobium. Neon is in E. And that looks like all the ones we have. Nickel. Yeah. Those are all our selections. N stands for nitrogen. 26. Choose the pair in which the components have the same charge. The same charge. Okay. How do we designate charge? We designate by the sign, either plus or minus, or it could be no charge. Right? That's a valid charge, no charge. And the other is what's causing the charge? Right? Is it an element? Is it an elementary particle? And how many of them are there? So let's look at our choices. Hydrogen atom and electron. Do they have the same charge? When we say hydrogen atom, we must assume that it's neutral. So A is not the right one, right? Right? A is wrong. B, an electron and a neutron, right? That's a negative versus neutral, right? That's not it. A neutron and a hydrogen atom, they're both neutral. They're different, right? But we're only interested in the charge. So a neutron and a hydrogen atom are both neutral. There's your answer. A proton and a hydrogen atom, proton and neutron, they're different charges. So we can throw these out also. C is your correct answer. All right, 28. And just move over here. The number of protons in the nucleus of an atom is called its, this is just definition. It's called the atomic number. 29. Which atomic particle determines the chemical behavior of an atom? Right? Think about what chemistry is. And in terms of Dalton's atomic theory, when atoms approach each other, whether they're individual atoms or they're parts of molecules, what do they see first? What's furthest from the nucleus? Electrons. The electrons, interactions of electrons and where they reside around the atom, that's what causes chemistry. So B, the electron, is your answer. Number 30. What is the most abundant element on the Earth, including the crust, oceans, and atmosphere? All right. It's the same as in the human body. When we say abundant, we mean mass. And where does oxygen reside in the crust? It's not oxygen gas, although there is a little bit there, but most of it is oxides of the metals, right? We have some metal and it's combined with oxygen, right? And the subscripts vary depending on the metal, right? But that's where the oxygen's located, in the crust. And in the crust, there's a lot of water also, right? In fact, just recently, very, very deep, actually, this isn't the crust. This is down into the mantle. There's like oceans and oceans of water in the mantle. But that doesn't answer our question. How about oceans, actual oceans on the surface of the earth? Most of that's H2O. Right? So there's your oxygen. All right. And the atmosphere? The atmosphere is 79% nitrogen and 21% oxygen. So combine those three, crust, ocean, atmosphere, and oxygen is the winner. 31. What did I say? 31? Yeah, 31. An atom with 15 protons and 16 neutrons is an atom of. What do we need to do to determine the element? All we need is the protons. It didn't ask us about isotopes or didn't ask us about mass number. It just said what element it is. So this is a case where demonstrating that word problems are meant to confuse. They give you information that you don't need, or they word it so that if you haven't studied the material, then the question confuses you about what the question is, right? In this case, all we need to know to answer the question is protons. 15 protons, right? That's phosphorus. There's your answer. Very simple. 33. A certain isotope, X with a 2+ charge, okay? And notice that when I read these word problems, I extract information from them so that the wording of the problem doesn't confuse me. What am I given? This one has 37 electrons and it has 73 neutrons. Okay, we may not need all that information, but there it is. That's what's given. What is the mass number for this element? So if we want the mass number, we have to add this to protons. How do we find the protons? You go back to the original given here, a 2+ charge. How does that element get a 2+ charge? It has 2 more protons than it does electrons. It's not balanced. It's unbalanced toward the positive. So if we know that it has this many electrons, it must have 39 protons. And 39 and 73 equals 112. That's your mass number. And the only way you're going to get good at this is to work lots of problems. The ones that we didn't cover today, work all of those. Because if you don't get bored working these problems, then you haven't worked enough of them. All right. How many phosphorus atoms are represented by one formula unit of cobalt-2 phosphate? And the author of the problem is kind enough to give you the formula. But if you didn't have the formula, you would have to know how to write the formula from the name. All right, so for 37, let's do it that way. Cobalt 2 phosphate. All right, cobalt. We know cobalt is this. We also know that cobalt has a 2+ charge, which means this is a type 2 compound. It has a metal that's drawn from the transition metals and some of further right hand underneath the nonmetals. Cobalt has a 2+ charge. Phosphate. Phosphate is a polyatomic ion. Look it up in that table. I gave you a table to do that. PO4 with a 3- charge. All right? Okay. How do you balance an even and an odd? You cross multiply. Bring that 3 over here, bring that 2 over here, and we have to have parentheses. Right? So there's your formula. Now, why did I put a parentheses here? Because polyatomic ions have a charge, but the charge does not belong to individual atoms. It's spread over the entire group. That means if you want more of that charge, you have to mean more groups, not more atoms. You cannot change the subscripts. All right. So now that we have the formula, the question is, how many phosphorus atoms? Well, there's 1 phosphorus atom here, and we have 2 groups. So we have 2 phosphorus atoms. Right? 2 phosphorus atoms. All right, we got another 39. Let's go ahead and erase this one. Make room for 39. All right, aluminum chromate. How many atoms are represented by this formula? Aluminum chromate. First of all, is that a valid name? Look at the metal. Does aluminum have a fixed charge? Yeah. When it's in a compound, aluminum has a 3+ charge every time, always. All right. Chromate. Look up chromate in that table, and you find that it's CrO4 with a 2- charge. Okay. Now, do the same things before. Cross multiply. Bring a 2 over here and a 3 over there. Okay. Now we have the formula that you were given. Now we add up the atoms. How many atoms are there? Well, you got 2 aluminums, you got 3 chromiums, and you got 3 times 4 is 12 oxygens. So that's 17. 17 atoms in this formula unit. All right, number 40. Which of the following statements are true? Okay, could be more than one. All right, so let's say we've got A, B, C, D, and E. All right, A is 2 only. B is 2 and 4. Okay, 1, 2, and 4. And D is 1 and 3. And the bottom one is all. All are true. Okay, what are our statements? All right, 1, 2, 3, and 4. Which are true. Models are always wrong unless they are proved by a theory. Does that make any sense? No. Models accompany the theory as a way of providing information about the theory, right? Models nearly always, theories don't have to have models, but most of them do. Models accompany a theory. So this one is false. Okay. 2, elements such as lead are made of tiny particles that mostly consist of open space. Well, yeah, atoms are mostly open space, right? You have a very dense nucleus where protons and some neutrons are combined in close proximity, and even there's some space. But the electrons out here, there's a huge amount of space. So atoms are mostly empty space. That one's true. How about 3? The air you breathe is an example of a heterogeneous mixture. This is the type of statement I like to work backwards. Is air a mixture? Yes. Is it heterogeneous? No, it's homogeneous. So this one's false. And 4, because ammonia always contains the same relative number of atoms, right? 1 atom of nitrogen, 3 atoms of hydrogen, it will always contain 4.6 grams of nitrogen for every 1 gram of hydrogen. Let's see if that's true. All right, what's the ratio? Well, if we take 1 unit of ammonia, right, and we say we have 1 mole, or we have 1 atom, how many atomic mass units of nitrogen are there? Well, let's see, there are 14. So 14 grams, if this were 1 mole, that would be 14 grams. Let's see, have we covered moles yet? Yeah, I think we have, because we balanced equations. Okay, we've covered moles. And 3, this is nitrogen. Hydrogen would be 3.03 grams. Why? Because 3 times 1.01, right? There are 3 hydrogens, so it's 3.03 grams. Now, what's the ratio? Well, we want to make this 1. So if we put 14 divided by 3.03, then that'll give the ratio of nitrogen to hydrogen. Grams. Okay? So if we divide 3.03, is 3.03 4.6? Let's do it this way. Rather than do that calculation, let's just say, to answer the question, 4.6 times 3.03. 4.6 and 3.03. Right, so that's 18 and 1 and 18 and 12 and 1 and 12. And we have 8, 3, 9, 3, 1. We have 3 decimals. So it's 13.9. Let's see. That doesn't seem right. No. I did something wrong. That's not right. I think we better do the, we better go ahead and do the division. I was trying an alternate method and it didn't work. So 14 divided by 3.03 is 4.6. So that's 4.6 grams of nitrogen for every 1 gram of hydrogen. So that's true. This one is also true. So 2 and 4, that means B is our answer. The reason that didn't work is I was multiplying to the ratio of 3.03 grams of hydrogen. So that would be 4.6 times 3.03 would give us the ratio of nitrogen to 3 grams of hydrogen. You have to divide them to get the correct answer. 42. Which pair has approximately the same mass? All right. Well, we know that protons and neutrons are almost exactly the same. Neutrons are just a hair heavier than protons. Electrons, no. Electrons and protons. Hydrogen atom and deuterium. Deuterium has, let's see, hydrogen has one here and one there. That's, I forget what they call the isotope for this one. Deuterium is this. It has one neutron. Tritium is this. It has two neutrons, right? And this one is, escapes me. Can't remember what they call that one. So our answer is A. Proton and neutron are about the same mass. 43. Okay. How many nitrogen atoms are indicated by the formula? Right. This is simple, just counting. AlNO2 3. AlNO2 3. How many nitrogen atoms? Well, we have 3 of this group, so 3 times 1 is 3 nitrogen atoms. Now, what if I ask you to name that compound? Is it a type 1, type 2, or type 3? Well, it's got a metal in it, so it's either a 1 or a 2. But we got to break the tie. Does aluminum have a fixed charge? Yes, it does. It has a 3+ charge. Right? And this is nitrite. So we say aluminum. Right? We don't have to say what the charge is because it's fixed. Right? We don't want to be redundant. And this is a polyatomic ion called nitrite. That's the name. Unambiguous and non-redundant. Skip a few, come down to 48. How many protons are in the atom carbon? All you have to do is look at the periodic table. You need to know the symbol for carbon. Then you look for it on the periodic table and you find it has an atomic number of 6. There's your number of protons. What does the symbol SN stand for? That's 10. From the Latin, let's see, I think it has 2 N's. Stannum. Okay. Many other examples. 55. How many protons, electrons, and neutrons, respectively, does this ion have? Protons, electrons, neutrons. Protons, electrons, neutrons. Okay? And the symbol is Sc with a 2+ charge and a mass number of 45. Okay? What is that? Sc is scandium. Scandium has 21 protons. Right? 21 protons. How many neutrons? Well, subtract 21 from 45. That's 24. Now, how many electrons? we have 2 more protons than we do electrons. That's why it's a 2 plus charge. So the number of electrons is 2 less than that. 21, 19, and 24. That's B. Number 61. The average mass of boron atoms is 10.81. So this is 10.81 is the atomic mass of boron, right? That means that this is the weighted average of all the isotopes naturally occurring on Earth for boron. Assuming we were able to isolate only one boron atom, what's the chance that you would randomly get one with a mass of 10.81? Right? In terms of percent, all the answers are in percent. The probability of getting one atom like this is 0%. This is a weighted average. This is not a representation of any single atom. All right. I didn't mark 62, but let's take a look at it. '62. All right. The first scientist to develop the theory that all atoms of a given element are identical. All atoms of a given element are identical. Oh, we covered that already. That's John Dalton, his atomic theory. The atoms of an element are identical to one another, but the atoms of different elements are different. Okay? What about the others? Right, we got our answer is John Dalton. That's B. What about the others? How about Thomson? What's Thomson's claim to fame? ON. Electron. He discovered the electron and he established the, let's see, how did he state it? Charge to mass? I think it was charge to mass. Charge to mass ratio. That's as far as he got. Let's see, who else? Lord Kelvin? Lord Kelvin. What did Kelvin do? Oops. Spell his name right. Kelvin. Well, for one thing, he gave us a new temperature scale, right? Kelvin temperature. He did a bunch of other stuff. He was working in thermodynamics at the time. But he needed to do that in order to flesh out his ideas about thermodynamics. How about the last one, Rutherford? Rutherford. His claim to fame was the nuclear atom model, right? So he took these electrons and he had to have protons in the nucleus and electrons out here, right? But he couldn't account for all the mass. So he gave the task to his research assistant, graduate student research assistant. And Chadwick filled in the mass gap here with neutrons. Chadwick discovered the neutrons. Nobel Prize, Nobel Prize. Now, one we left out, one that's left out of most discussions is Millikan. Millikan. He worked with the electron. He did other stuff too, but he worked with the electron and he actually determined the mass of an electron. See, Thomson only did the charge to mass ratio. Millikan took it the next step and actually found out what is the mass of an electron. All right, so let's go on to the next marked one. 65. Which of the following elements is most similar to chlorine? When we say most similar, what do we mean? Well, in chemistry, we mean chemical behavior. How does chlorine behave? And what other elements behave like chlorine? The members of its group, right? The column. Chlorine is a halogen. So who's going to behave like chlorine? Fluorine, bromine, iodine, astatine. Those are all halogens, right? So which one of these is the best candidate? Bromine. Bromine is a halogen. Now they have different physical properties, right? At room temperature, chlorine is a gas, right? Like that. This is a gas. Bromine is a liquid, and iodine is a solid. So is astatine. All right, so they have different physical properties, but their chemical behavior is very similar. All right, down to number 70. We're doing on time, okay? We've chewed up an hour so far. Number 70. How many protons, electrons, and neutrons, respectively, does 31P have? 31. That's phosphorus. So if we look on our periodic table, we see phosphorus has an atomic number of 15. Now we can answer the question. And this is a neutral atom, right? So protons, electrons, neutrons, these two are going to be equal, 15. And this one's going to be the difference, 16. Okay? Very simple. 71. Which of the following contains the largest number of oxygen atoms? All right, so you just have to count them up. A, B, C, D, and E. All right. First one, 4 waters. 4 water molecules. 1 per molecule, so 1 times 4 is 4 oxygen atoms. Oxygen atoms. How about the second one? O3. O3, that's just 3. How about H2SO4? H2SO4 is 4. And 3 CO2s, 2 per molecule times 3 molecules is 6. And AlNO3 taken 3 times. AlNO3, 3 times 3 times 3 is 9. So there's your answer. That's the most. Name this compound. Right. This is carbon dioxide. This is sulfuric acid. This is ozone. That's water. This is aluminum. Nitrate. That's it. That's all you have to say. 72. How many atoms of oxygen are in one formula unit of calcium dihydrogen phosphate? This one you have to know how to write. So we know it's got calcium in it, right? And dihydrogen phosphate is a polyatomic ion. Just look it up in your table. Dihydrogen phosphate. What's the charge? It's a -1. This is a 2 plus. So that means we need 2 of these to balance those 2 pluses. Now we can answer the question. How many atoms of oxygen? There's 4 in this unit, but there are 2 of them. So there are 8 oxygen atoms. Okay. Let's see. How about 75? Which of the following statements is true? Roman numerals 1, 2, and 3. 1, 2, and 3. So let's see. The first statement says the number of protons in an element is the same for all neutral atoms of that element. Yeah, that's definition, right? The neutral atoms of an element, actually, neutral atoms and ions of an element will actually have the same number of protons. You don't change the number of protons. The number of protons identifies the element, right? So this one is true. How about Roman numeral 2? The number of electrons in an element is the same for all neutral atoms of that element. The number of electrons in an element is the same for all neutral atoms. In that case, the number of electrons equals the number of protons, and that makes it the same as number 1. Right? They will have the same number of electrons in the neutral atoms because they're equal to the protons. Number 3, the number of neutrons in an element is the same for all neutral atoms of that element. Nope. Why? Isotopes. So that one's out. And we only have 1 and 2. That's B. Now we're into chapter 5. We might be able to finish today. Chapter 5. Chapter 5, number 76. The correct formula for carbon monoxide, naming compounds. Carbon monoxide, is this a type 1, 2, or 3? 2 nonmetals, it's a type 3, which simply means that we say how many atoms there are. Carbon monoxide, 1 carbon, 1 oxygen. That's it. That's carbon monoxide. 77. Which of the following is a binary compound? A binary compound. Okay. The author's definition of a binary compound is only 2 elements in the formula, right? So E is not considered a binary. D is not a compound. C is a compound. It has hydrogen and sulfur. Okay. H2SO4 is not considered binary, and sodium hydroxide is not considered binary either because they have more than 2 elements in them. Now, when we name them, we treat them as if they were binary. But by the author's definition in your textbook, the only binary one is hydrogen sulfide. 79. The correct name for an aqueous solution of HC2H3O2. HC2H3O2. Aqueous. Okay. 2 clues here as to what naming convention you use. One is the first element is a hydrogen. That's an acid. If we put it in aqueous solution. That's the other clue. Now we use the acid naming convention. Is there oxygen here? Yep. So we do not say hydro. We simply go to this part of the molecule, separate from that hydrogen, say, what is that? Well, it's going to be this polyatomic ion, acetate. We take the ending and convert it to IC and add acid. Acetic acid. That's the name for that compound. 80. All right. Na plus represents what? Well, the element is sodium, but it has a charge. So we would say sodium ion. Now, we don't have to say how much the charge is because sodium is an alkali metal. It's always a +1 charge. So we just say sodium ion, and that's this right here. Okay, 81. I put 81 in here because of mercury. How does mercury exist as an ion? Mercury exists as an ion. It has two possible charges for the mercury atoms, but as an ion, it's always 2+. It's either this or this. See the difference? One atom, two atoms with the same charge. So what does that mean about the individual atoms? What's the charge on this one? Well, the charge on that one is a 2. The charge on each one of these is a 1 because there are two of them. 2 times 1 is 2. So what we're looking at here is a mercury 1 ion. Okay. Next, 82. What's the correct name of the compound that results from the most stable ion of sulfur and the metal ion that contains 24 electrons? Okay, let's put what we're given up here. The most stable ion for sulfur is 2-. Sulfur is a chalcogen. It's in the oxygen group. And when it's an ion, as stated here, it's a 2- charge. Okay, now for the metal. Metal, we're told, contains 24 electrons. Now, there's an assumption we have to make. We have to assume that there's only one metal with this sulfur. Okay, maybe we need more than one sulfur, but we've only got one metal. And this metal has 24 electrons. Okay, so which means what? Well, if we say this metal has to balance that 2- charge, then this one has to be a 2+ charge, doesn't it? Yeah, has to be a 2+. So if that's a 2+ charge, then how many protons do you have? You have 2 more than you do electrons. So 26 protons is iron. Iron with a 2+ and sulfur with a 2-. Right? So name the compound. Iron 2, Roman numeral, 2 sulfide. That's D. 83. Symbol for rubidium ion. All right. So we know that the element symbol for rubidium is that. Where is it located? Rubidium is an alkali metal, it always has a +1 charge when it's an ion. Right? So D, Rb +1 charge is the answer. Correct formula for barium hydroxide. Okay. Barium and hydroxide. Hydroxide is a polyatomic ion with a -1 charge. Barium is an alkaline earth with a 2+ charge. So we need 2. BaOH2. Lead 4 nitrate. This is 85. Lead with a 4+ charge, nitrate, polyatomic ion with a -1. So we need 4 of these to balance. That's D. Now we're going to name the acid HNO2. When it says name the acid, you must assume that it's aqueous solution. If we're going to name it as an acid, it must be an aqueous solution. So let's go to A6. And the formula is HNO2. HNO2 has oxygen in it. So we go to this part of the molecule. This is nitrite. And ites become us. Nitrous acid. 87. The correct formula for the ammonium ion. You used to have to look that one up in the table. The ammonium ion is that. How about 88? The name for AlOH3. 88. AlOH3. Oops. My mistake. There. This is hydroxide. Aluminum has a fixed charge. This is a type 1 compound. Aluminum hydroxide. Right. Any of you have an upset stomach and take this medicine called Maalox? Heard of Maalox? You get 2 compounds in that one. This is one of them. Aluminum hydroxide, and the other one is magnesium hydroxide. Right? Thus the name. Let's see, MaAlOX, I think. It's 2 A's. Derived from magnesium, Ma, and Al, aluminum. Okay, 89. All right. '89. The correct name for an aqueous solution of HCN. HCN, aqueous. All right. No oxygens. So we start this name with hydro. And we take this group and say, what is that? That's cyanide. And I becomes ic. Cyanic acid. Hydrocyanic acid. All right, 91, we have to decide which one of these is actually a correct name. Let's see, how many do we have? A through E. A, B, C, D, and E. Are these unique? Yeah, each one is unique. So we're looking for the correct one. HCl. HCl is hydrochloric acid, right? That's not it. HNO3 is nitric acid. Nitrate with an oxygen, 8 becomes ic, nitric acid. That one's good. That one's true. So we found our correct answer. Let's go ahead and look at the others. NH3, right? That's ammonia. NH4 sub 3 PO3. This is ammonium PO3 is phosphite. Right? So that one's wrong. And the last one, H2SO3. Right? SO3 is sulfite. Ike becomes us. Sulfurous acid. There you go. So B is the only one that's correctly named. 92. The substance ClO3 is best described as ClO3 minus. This is the chlorate ion. Okay. So what is it? It's not a polyatomic molecule. It's a polyatomic ion. That's B. Moving on. Let's see how we're doing here. 97. Okay, we got a half hour to go. 97. Sodium chloride has the formula. Sodium. What's chloride? ClO2 minus. That's chlorate. Minus one oxygen is chloride. Okay? That's it. One positive, one negative. A is your answer. 98. The correct name for an aqueous solution of H2SO4. SO4 is sulfate. 8 becomes ic. Sulfuric acid. All right. And 101. Let's see. I take earlier I said I used the mole. Now we have talked about it because it's an SI unit, but we haven't balanced equations yet. That doesn't come. So I was wrong there. We have not balanced equations. We're still writing words, compound. So 101 says the formula for the compound formed from the polyatomic ions NH4 and PO4 3 minus. The formula NH4 and PO4 3 minus, right? We just balance the charges. We need 3 of these, right? Like that. NH4 sub 3 PO4. That would be A. Correct name for an aqueous solution of HCl. Aqueous, 103. Aqueous is, we say hydro, because there's no oxygen. And chloride becomes chloric, hydrochloric acid. That's it. Really simple. Practice, practice. Pi3 is named what? 105. Pi3. That's phosphorus. This is iodide. Iodine with an IDE ending on it. This is a nonmetal, so this is triiodide. Triiodide. 107. The name for PB4 plus. PB4 plus would be lead 4 ion. (111) What's the formula for selenium trioxide? Selenium and oxygen. Now, are they nonmetals? The name implies that they're nonmetals because the prefix tri. So we look it up. Yep. Selenium is in the chalcogen group, oxygen, sulfur, selenium. And so we say selenium trioxide. That's it. 15. 115. All right, what do we have to do? Which one is not named as an acid? Okay. A, B, C, D, and E. They're all unique. All right. Which one is not named as an acid? All right, here's a clue. Which ones start the formula with a hydrogen? They're all in aqueous solution, right? So that's not a problem. A starts with a hydrogen. That's an acid. C, D, and E all start with hydrogens. B does not. NH3, aqueous, is not acid. Right? We'll talk about it later, but actually it's a base. Don't name it as an acid. In fact, NH3 has a special name of its own. That's ammonia. There are some compounds that have special names, like ammonia, like water. We don't say dihydrogen monoxide. And we don't say dinitrogen trihydride. We say ammonia. 117. All right. What's the formula for gold 1 oxide? Well, gold is that. It has a 1 plus charge. Oxygen has a 2 minus charge, so we need a 2 here. AU2O. 121. The carbonate ion has the formula CO3 2 minus, right? A polyatomic ion. What is the correct formula for sodium carbonate? Okay. Sodium always has a +1 charge. Carbonate has a 2 minus charge, so we need a 2 here. Na2CO3. 124. Which of the following represents the hypochlorite ion? Remember that sequence. right? Chlorate, 8. Chlorite, perchlorate, hypochlorite. Cl minus is the hypochlorite ion. 125. What is the formula for calcium hydroxide? Calcium is an alkaline earth. It always has a 2 plus. And hydroxide is a polyatomic with always -1. So we need 2 of them to balance the charges. CaOH taken twice. 127. The name for HBRO. HBRO. Right. Note and look at the choices you have. They're all in terms of an acid. This is also a clue here. Aqueous with a hydrogen. So we don't start with hydro. We look at this part of the molecule. What is that? That's hypobromite. So we say ite becomes us. That's hypobromous acid. All right. 128. They want us to name H2SO3, and all your selections are acids. So even though we have not put aqueous out here, your only choices are acid. So you got to choose it, name it like an acid. This would be sulfite or sulfurous acid. 129 is next, isn't it? Correct name for P2O5. P2O5. 2 nonmetals. So we just say how many there are. Diphosphorus. Penta oxide. Actually, we dropped the A. It's just pentoxide. We do that for aesthetic reasons. It just sounds better. All right. Who's next? 132. The correct formula for silver iodide. Silver iodide. So that means we have the iodine ion and we have the silver ion. Remember, silver is one of those transition metals that has a fixed charge. So the name silver iodide is correct for AgI. That's it. Unambiguous, not redundant. Lots of repetition, lots of practice. 140. Correct formula for lead 2 sulfite. Lead 2 plus, the formula tells us the charge. Sulfite, SO3, 2 minus. That's it, PbSO3. 142. Let's see, the correct formula for the carbonate ion. You just look it up. Carbonate. That's it. CO3 2 minus. 143. A compound contains an unknown ion, X, and has the formula XCl2. Okay? So it has 2 atoms of chlorine, 1 atom of this. Now, it could be a metal, it could be a non-metal. Are we given enough information? Yes. We're told that this is an ion. So chlorine would be a -1. This would have to be a +2. It's a metal. Now, does it have a fixed charge or does it have a variable charge? Let's see. Ion X contains 20 electrons. So this has 20 electrons, which means 22 protons because of that charge, right? You need 2 extras. So 22 tells us how many protons. That would be titanium. So this is titanium with a 2+ charge and chlorine with a 1-. So what is the identity of X? X is Ti 2+. 147. The name for NaHCO3. All right. NaHCO3. Recognize this as a polyatomic ion. That has a +1 charge. This has a -1 charge. So let's name it. Type 1 compound. Sodium is a fixed charge. So we just say sodium, hydrogen, carbonate. This is the polyatomic ion. Now, if you just go to, if you just Google it, right? You want to answer a question, you just Google the answer. It might tell you sodium bicarbonate. That's the old version. This is the way we name it now. If I ask you a question and you say bicarbonate, you're wrong. It's not bicarbonate anymore. Although that's one option that's given here, it should be sodium hydrogen carbonate. Now, of course, if you look on the package of Arm & Hammer, sodium, baking soda, it might say sodium bicarbonate. You know, that's just the way it is. How about this one? Correct name for an aqueous solution of H2CO3. 148. 148. This one's starting to run out. Try this one. H2CO3 aqueous. H2CO3 aqueous. All right. Oxygens. So we look at this part of the molecule. That's the carbonate. Polyatomic ion. 8 becomes ic. So it's carbonic acid. That's it. That's what you drink when you drink pop. Carbonic acid. Don't worry, it's a weak acid. 153. Let's take these out. 153. The name for NH4Br. NH4Br. This is a polyatomic ion, ammonium. You don't have to say what the charge is. All polyatomic ions are fixed charge, so we treat them like type 1 compounds. Well, this is the only one because that's the only cation in the group. The rest are negatives. And this is bromide. Ammonium bromide is the proper name. You don't say ammonium 1 bromide, that's redundant. It's just ammonium bromide. 155. The formula for the compound formed from ammonium and sulfate. Right, so we say ammonium, the formula, has a +1 charge. Sulfate is also a polyatomic with a 2- charge. So we need 2 of those positives to balance that one. NH4 sub 2, SO4. That's D. And we're done. Okay. So that means we'll come back on Thursday, the 12th, and I'll be available for tutoring. I'll stick around for 20 or 30 minutes. If nobody shows up, then I'll shut it down. And you can always get in touch with me, of course, by other means that are in the syllabus. But we finished the review for this exam, and this was a buffer day. So now Thursday becomes the buffer day, and we'll use it as a tutoring session, question and answer. All right, that's it for today. Let me stop the share and end the meeting.